Hi, welcome to the last session of Monday on the Open Security Summit session in October 2023. And we have Matt Adams, who's going to kickstart a lot of our sessions we have dedicated to LLMs. And this is going to be on the AttackGen, which is a really cool tool and technology he's been working on how to actually start creating simulations. And I was just mentioning, I think is the kind of tool and the kind of use of LLMs that I think is super useful, and we can add a lot of value these moments with the LLMs that we have. So Matt, over to you.
Thanks very much. Good afternoon, good evening, good morning, everyone. Thanks for joining wherever you happen to be watching. So just to introduce myself, my name is Matt Adams. I'm a security architect at Santander UK. I've worked in cybersecurity for almost 20 years. So I started out as a Big Four consultant with one of the big cybersecurity practices. I then became an independent contractor working across government and financial services sectors. And then in recent years, I've taken up permanent security architecture roles with Costa Coffee, part of the Coca-Cola Group, and latterly with Santander. And when I'm not at work, I've got a few but quite varied hobbies. So I live on a small holding in the North Buckinghamshire countryside in England, which is where I'm joining you from this evening. And when I'm not out in the fields looking after sheep and chickens, I've got my own home lab, and I enjoy coding my own projects, which is where a lot of this experimentation with large language models has come from, really, as I've looked for ways to take problems that I come across in my day job and in my personal life, and look to see how I can apply those models to make myself and my colleagues and others more efficient and more productive. So our agenda for the talk, just going to try and bring everybody up to speed on what I think is the current position with incident response testing. We'll then take a dive into the architecture and building blocks of this tool that I've developed called AttackGen. I'll then give you a couple of demos of the tool. We'll look at the roadmap is perhaps slightly too grand a term, but the next things that I'm thinking of for building on version 0.2 of the tool that's there at the moment. And then I'll wrap up with some of my thoughts on how do you ideate use cases for language models, and what are some of what I would consider to be the best practices when it comes to implementing these types of tools in an organization. And if we've got some time, I'm happy to take questions at the end. So incident response testing, for me, again, I'm a security architect. This isn't my sort of day in and day out job, but I have participated and run incident response exercises in the past. For me, incident response is a skill, and like any skill, the more you practice, the more you refine, the better you're going to be at it. And so you'll see that those teams that exercise more and have more practical experience of live responses are understandably more efficient and better at responding when it matters. And so I really like the following quote from Alan Iverson, who has nothing to do with cybersecurity or incident response. He's a former NBA basketball player. But I like it because it captures a couple of different aspects of incident response testing. And his thought is that when you're not practicing, someone else is getting better. And I think of this from two perspectives. One, this could be your competitors, other organizations who are hardening their defenses, getting better at mitigating attacks sooner within the life cycle of an attack. But it also applies to the bad guys, to our adversaries. They're constantly improving and trying out new attack techniques. And so it's important that we continue to practice, we continue to improve our own games when it comes to incident response. And for organizations that are testing and exercising at the moment, They are including, they are taking account of this increasing complexity, but it is becoming challenging to capture within an incident response scenario. So what you'll see is that leading organizations have moved to quite complex and threat-driven testing scenarios. So probably one of the best cases or best examples of this is the CBEST scheme that's sponsored by the Bank of England here in the UK. And that takes threat intelligence from leading threat intelligence companies. It combines that with assessments from the intelligence services and other very advanced threat intelligence sources. And they then use that to produce a realistic testing scenario based on an adversary or adversaries that they wish to simulate during that exercise. Clearly, that's not achievable for all companies. And those companies that aren't large financial services institutions or critical national infrastructure, they're not really able to replicate both the specificity of those scenarios, or also the complexity, simply because they lack the time and financial resources to achieve that same depth of testing. So what we kind of see at the moment then is in more generic incident response scenarios being used by smaller organizations. And the reason why I'm not a particular fan of those is because they don't really account for the organizational context that is relevant to those particular companies. And it may be that you're picking up a very standard phishing based incident response test, but you may have really good email defenses, and actually you get quite a few phishing attacks that hit end users, and you'd be better testing something that was more relevant to your organization. If you did want to develop more tailored and specific scenarios, well, that tends to come with a longer lead time and cost to produce those scenarios. So some of the testing and exercising that I've been involved in the past, I've spent sort of end to end, maybe 3-4 months working with a consultancy to go from the sort of inception of an idea for a scenario that we want to test, all the way through to developing that scenario, creating new injects and content to put into that exercise, and then finally getting people around the table to go through and exercise that properly. Because of that lead time, my experience is that there's a bias towards larger scale tests, with the side effect that tests tend to become less frequent. So you might have the scope to do one of those a year, which I think is less than ideal, and more teams would benefit from being able to focus on doing smaller tests more frequently, to supplement those large scale tests. And that was really where the idea for AttackGen came from. And what AttackGen is it's a combination of the MITRE ATT&CK framework, so the data from the MITRE ATT&CK framework, combined with an OpenAI LLM, so in this case GPT 3.5 Turbo, and I'm also then using a framework called LangChain, which is I think quite a few people are aware of it now, but it's a framework for working with language models like the GPT series, and it just makes it easier to handle some of the prompt formatting, and that's really where I'm using it for in this tool. And lastly, there's a simple but I think fairly effective UI delivered through Streamlit, which is a Python library, which I use for quite a few of my POC tools.
Matt, can I ask you a question? Have you experimented with 4 or with Claude 2 or Llama 2, the other sort of GPT models?
I have, yeah. When you're using different models though, and LangChain does try to compensate for this. because the model's been trained and fine-tuned on different data sets and different prompt structures, the way that Claude, for example, will deal with a user and AI response, that prefers, I think, XML. It does really well with sort of XML structured documents, and you've got quite a particular structure that you need to give it to get the best out of the prompts. Whereas OpenAI is a bit more transparent. You don't have to have as much work going into telling it, this is the user section, this is the assistant section. And so trying to switch between, for example, GPT 3.5 and Claude 2 in this tool, I have tried to do it. There's quite a lot of work that needs to go into re-engineering the prompts to get consistent results. And so for the time being, I've left it just as a OpenAI only tool at the moment.
What about GPT-4?
So GPT-4 would do a really good job because of the length of the responses. I favor 3.5 Turbo just because it's quicker, and because of things that you'll see later on in the presentation. I can work with the slightly less capable model and still get, I think, good results from it.
Yeah, that was going to be my next question, because I found also that 3.5 can actually be really good. And there's an interesting trend here, which sometimes we don't need very powerful models if we can prompt it quite effectively, isn't it?
Yeah, absolutely. I think there's a lot you can do with fine tuning and prompt engineering to get really good results from 3.5.
Brilliant.
So just to check that we're all on the same page when it comes to MITRE ATT&CK, because that's a fairly key part of this tool. ATT&CK is a knowledge base of adversary tactics and techniques. And the key to it is that it's based on real-world observations from security analysts around the world, where they're monitoring different threat actor groups, and they see these different behaviors and techniques used by them. ATT&CK is a really good way of cataloging those observations and then subsequently using them to develop threat models that we can use downstream. And probably the most important feature, I think, of ATT&CK is that it gives us a standardized framework to be able to understand and communicate threats, so that I know if I'm in a security architecture team and I'm talking to a problem that's been detected by our incident responders, when we say lateral movement, we're both talking about the same technique that was used to move laterally from host to host. And so it takes away a lot of the potential for confusion that could otherwise result. And so what you can see in the image here at the bottom is a heat map that's produced by a tool called Attack Navigator. And this is a mapping of some different techniques that are used by two different threat actor groups, so APT3 and APT29. And you can sort of see the power of being able to map on those different techniques, because it tells you where you should probably focus your efforts in terms of defending against them.
So have you tried reverse engineering an attack into the MITRE framework? So you basically say, here's my attack, here's the scenario, now give me this path.
Yeah. Remind me about that when we come to hallucinations, because yes, that's was an example I wanted to give. Yeah. So if ATT&CK is that good, and I'm sure lots of you have heard many things about the ATT&CK framework, why do you need a tool like AttackGen in addition to it? And in my experience, there's quite a learning curve to ATT&CK. So people get the concept very quickly of the knowledge base and being able to have a common language, excuse me, for discussing different techniques and threat actor groups. But when you get down and use it at a practical level, you quickly come across these long lists of techniques that are associated with each threat actor group. And that, in my experience, is where people sort of tend to get a bit bogged down, because trying to get those then into something that's useful beyond just the basic understanding that a threat actor group uses, technique A, B, and C, actually getting something of value out of that is a bit more difficult. And it takes time to learn how to use Attack Navigator, how to create different layers, all of those sorts of things. And what AttackGen does is it tries to flatten that learning curve and reduce the time for people to get value from the attack framework. So what you'll see is that we can quickly select a specific threat actor group, and then within a minute or two create a realistic testing scenario that we could give to our security management or our incident response function, and ask them to build a response exercise around that. And then there's a bit of an overview of how AttackGen works. And you'll see this in the demo in a few minutes. But first off, we just ask the user to provide an API key for OpenAI, and to provide some very high-level information about their chosen industry and the size of their organization. And that's just to provide a bit of additional context to the model. They then select whether they want to run a threat group scenario, which is the example we've just covered, which is you select a threat group, and you then get a list of associated attack techniques back from the tool, which is then used to generate a scenario. Or recently in version 0.2 of the tool, I introduced this feature of custom scenarios, where really the idea is that for organizations that have got quite advanced threat intelligence capabilities, there may be threat actors that they're tracking that aren't in the attack framework at the moment. And so they need a way to select specific techniques and then build a scenario around those particular techniques, again, quite quickly, but quite realistically. Once the data has been selected, so those particular techniques have been pulled from the attack framework, they then go into a LangChain prompt template. So as I've talked about, LangChain is that framework that we use for working with LLMs, and it then allows all of that context in terms of the industry, the company size, the relevant techniques, all to be passed to the LLM in one go, with a request that says, you are an expert cyber incident responder. Please produce a scenario that incorporates all of this information and context that we've provided. When that run occurs, there's an option to log that to a tool called Lsmith, and I'll go into a bit more detail about what that does in a slide or two. And I've also recently introduced the ability for users to provide feedback on each generation, and that's really just something that I'm using to understand how well the tool is performing, and whether it's producing the desired scenarios, or if there's some issues that I need to delve into in a bit more detail. So this seems like a lot of work, right? So when you can ask ChatGPT to produce an incident response testing scenario, and it will produce something like you see on the left-hand side of the slide, why don't we just use that? Well, as you can see, just stepping through this, I asked ChatGPT to give me a scenario for APT 41, also known as Wicked Panda, and I tried to make the prompt that I submitted as close to the prompt templates that AttackGen uses to make this a representative test. So you can see that we're passing in this information that it's a large organization, and that in this case, it operates in the insurance industry. And then ChatGPT starts to generate the threat actor profile and the techniques associated with that threat actor group. And this is all looking very credible, very reasonable as a means of explaining what this threat actor is doing in their processes. So, spear phishing attachments to gain initial access, execution of PowerShell scripts, establishing persistence through scheduled tasks, exploiting vulnerabilities to get privilege escalation, all very credible. But when you go and map this back to the actual listing for APT 41 on the MITRE ATT&CK website, you'll find that several of these are actually not relevant for this threat actor group, which is a real problem if you're trying to produce realistic scenarios specifically for a given threat actor group. So as we can see, GPT 3.5 and even GPT 4 will hallucinate the names of techniques, and most commonly the attack IDs. It seems to really struggle with matching the specific attack IDs to the name of the technique. Do you get quite a number of variances there? So having mentioned hallucinations, I thought it was probably apt to talk in a bit more detail about what a hallucination is. Probably most people have heard about it who've looked at LLMs, and it's one of the key weaknesses of these probabilistic models. And so I thought, well, what better option than to ask ChatGPT what a hallucination is? And in the response, it says that they're a phenomenon where a machine learning model, particularly a language model like GPT-4, produces outputs that seem plausible, but are actually incorrect or nonsensical. So exactly what we saw in the previous previous slide, and I think a really good answer. What then caught me by surprise was then the hallucination that it follows with by saying that an LLM stands for low-level mistake, which, if you're not familiar with this space, again, you could find completely credible and quite difficult to spot. But it sort of highlights that you continue to need this subject matter expertise to know what you're looking for, or otherwise be prepared to be caught out when it comes to this type of generation.
So that's a meta hallucination, right? Hallucination on the explanation of hallucinations.
Yeah, I did wonder if I was being trolled by the model at that point, if it just thought it would throw that in there. But yeah, and that was the first question. I didn't do this repeatedly. That was the first time I answered it. I thought it was too good not to.
Yeah, that's definitely a keeper. I agree with Sarah.
So to Dennis's question earlier about reverse engineering attacks, that was one of the first ideas I had when I looked at the GPT models, was the idea that if you could take a news article or maybe just a very brief threat intelligence bulletin that had been produced, perhaps you could pass that to a language model and say, identify all of the relevant attack techniques in this article and give me the references for them, the attack IDs for them, according to the MITRE ATT&CK framework. And while, again, it looked very credible, I soon found that when I started to check a number of these, what you saw a couple of slides ago happened with great regularity, in that it just wouldn't nail the attack IDs to the technique names. There was always some variation. And so when I was coming to think about AttackGen, I decided to take a different approach and not rely on the language model to produce that important mapping, which is really obviously critical to the integrity of the scenarios. So there's a bit of a complex, fairly complex sequence diagram here, but the bit that we care about is in the first steps. So after we've logged into the Streamlit app and we've set things like the API key and our industry and company size, the user then selects a threat actor group. And at that point, I'm using a very useful Python library to just load in the MITRE ATT&CK framework in its STIX data format, STIX, and it's then filtered, again using just a bit of Python. It filters out all of the relevant techniques for that selected threat actor group, and then it's returned back to the Streamlit UI. At the point the user clicks generate scenario, that's when the selection of those techniques and their associated IDs is made from the application and then passed to the model. So I'm not really giving it much of a chance to hallucinate those. I'm not saying it's never going to do it, but by including those in the human input prompt for the model, I found it to be, very effective at managing hallucinations. I've not come across an instance where I've sent it a list of techniques and attack IDs and found that in the response the model has hallucinated something different. So from my experience at least, it looks to be very reliable. When we were walking through the block diagram earlier, I did touch on Lsmith, and I wanted to include this because I think this topic of observability and feedback capture from LLMs is going to be increasingly important as we go from this phase when everybody's got incredibly excited about language model applications and running various POCs. But when you take them to production, I think, and quite rightly so, we get increasing challenge from stakeholders to say, can you explain to me how this model works? And the models are probabilistic. You can only go so far. But I think tools like Lsmith are very useful in at least providing some level of visibility into the inner workings of the model. And so that's why I wanted to include support for it with version 0.2 of AttackGen. And so it allows that greater level of monitoring and the ability to capture user feedback as well. So you can see on the right here, we get visibility of the system prompt that's being passed to the model as part of the generation request. You can also then see all of the populated prompt template that's then being given to the model. So that data, all of those techniques that we filtered through for this particular threat actor group, that is where those appear, and then they're submitted to the model as part of that generation.
And all this code is open source, right? This is all an open source project you release.
Yeah.
Very cool.
And then, interestingly, then when you're using Lsmith, you can also see the responses back from the AI. So if you're developing in-house tools in an organization and you want to have a look at what types of requests are being submitted and how the AI has responded, if you got a bit of poor feedback from a user, you can then go back and look at the log of the actual output that was generated to see potentially what went wrong and maybe tune your prompts, or even look at fine-tuning the model to get some better responses. Okay, so time for a demo. So this is the AttackGen Streamlit UI. I've already pre-populated the API key that I'm using, and we'll just select an industry at random. We'll be a media company, and we'll say we're a large-ish media company. And then this is where we split into choosing a threat group scenario. We've then got all of the threat actor groups that are currently logged in the MITRE ATT&CK framework. So let's pick Carbonac. They're reasonably high profile. You can always look at the listing for Carbonac or the given threat actor group on the attack framework. That's linked to dynamically when you select it. You can also then see the different techniques that are being loaded in. So behind the scenes, what's happening is we're using that attack Python library that I mentioned to pull data from the sticks data and then load that into a pandas data frame. And then just a bit of formatting occurs just to make it a bit more presentable to the user. You'll notice here that like lots of threat actor groups, this group has sometimes multiple techniques within a given phase. And what I've decided to do, rather than having sort of really complex or overlapping scenarios, is that when we come to generate the scenario, if there are multiple techniques per phase, one of those techniques will just be selected at random. So you shouldn't see more than one technique per phase. And that's just to keep things, you know, relatively well structured. If you've got a requirement to consider sort of multiple techniques for, in this case, defense evasion, that's where the custom scenario generation would come in. So hit generate scenario. This is a recent feature that was introduced by Streamlit, which I quite like, which is the ability to give better visibility into long-running processes. So rather than just having a spinning wheel here with the user wondering what's going on for a minute or two, we can see that the model's been initialized successfully and the scenario generation has proceeded. It's fairly straightforward in this case, but where you've got tools that perhaps have multiple agents talking back and forth, where the user might be waiting for several minutes for their output, I think that things like that are really nice UI tweaks that you can use just to give the user a bit more insight into what's going on, and so they're not left thinking that something's stalled somewhere. And then this is our incident response testing scenario. So you can see that we've picked up the relevant details from the prompt template in terms of type of company, size, and the threat actor group. It's then creating the scenario based on the techniques that we selected. And if we then flip over to Lsmith, which was that observability tool I mentioned, you can see that this is our latest run here. So all of that information will then be logged. This is only if you're using the Streamlit live demo app, by the way. So if you clone my repository and you run it on your own, you can use your own Lsmith API keys and set it up yourself, or remove the environment variables altogether. The reason why I tested using Lsmith with this tool is because really there's not any organizational identifiable information beyond it's a media company with a couple of hundreds or 1,000 employees. So in terms of sort of demoing the capabilities of Lsmith while not creating too much of a headache for myself or people wanting to use the tool, this felt like a good time to use it. And then finally, if we're happy with that, we can submit our feedback, and then that will also appear with the run. So it's a good way of then keeping track. I could extend this so that if a user submitted negative feedback, they could provide a comment to explain what was wrong. It's not something I've done in the public version of this at the moment. And then if we flick over to custom scenarios, so just to give you an idea of how we would use this. So if we've got perhaps a phishing email for initial access that might drop some malware, and we'll think about lateral movement through RDP and maybe some exfiltration over a C2 channel. Again, we can hit that generate scenario, and it will take a few seconds to generate that. So while that's waiting, I'll just point out that you can immediately jump to the code on GitHub to look at this. And as Dennis said, it's all open source. So while we're waiting for that, I'll give you a look at the prompt template that's used for the custom scenarios. So here you can see that this is our system template, which is pretty consistent. And then when it comes to specifying the human template, this is where we capture the industry and company size parameters. Those will then be, for want of a better term, stuffed into the prompt template, along with the techniques that the user has selected. And so once that's all populated, that's what then gets submitted to the language model. And so again, that's our scenario generated, and we can see that in Lsmith again. So slightly different output this time because we're asking for a custom incident response testing scenario. It's also interesting to track the some of the latency around the request. So another useful feature of this observability platform is, you can see that this is probably a scenario where there were quite a lot of techniques that were listed. So is this for APT 29? Yeah, so 13 techniques were submitted. So the model is obviously going to take a bit more time to think about how to work with those. Okay, and if you'd like to try AttackGen, obviously I've mentioned the GitHub repo already. You can use the Streamlit community cloud app as well. You can obviously clone or fork that app as well and run it on your own infrastructure.
Have you tried with Azure Open AI, or somebody tried it?
Yeah, so Azure Open AI is a lot closer to sort of API formats for OpenAI. Interestingly, not identical though. So again, it sort of suffers from the same problem around prompt engineering. You've got to tweak the prompt slightly in order to get representative responses, but in principle, with a bit of coding work, it's absolutely possible.
Yeah, because I think the advantage of that is that you would solve that problem of, if you want to run this for your own more external sensitive data or with live incidents, right? Then yeah, it's kind of, at least that one doesn't send the data to ChatGPT.
Yes, yeah. I mean, OpenAI say that anything submitted to their API or via the playground, they don't use to train their models. Clearly, though, if you haven't got commercial terms with OpenAI, but you do have commercial terms with Azure, then there's obviously a clear choice into which one you'll use. But it's not something that I've looked to integrate into this tool yet. But yeah, I have done for other projects that I'm working on.
Cool.
So just to give you an idea of what you might see next. From AttackGen, I'd like to add some support for additional matrices from the attack framework. So those of you who are more familiar with MITRE ATT&CK will recognize that we've only been talking about the enterprise attack matrix so far, but my plan is to add support for the mobile and industrial control system matrices. Also with an eye on making this easier to deploy in corporate environments. I'm planning to provide a Docker container image rather than having you either run it from the Streamlit app or build it from source each time.
Could you run it from actually could you run it from a Lambda function? I guess depends if I'm not sure what Streamlit support for Lambda functions is.
I've not tried to run Streamlit through a Lambda. That would be interesting. I'm not sure. It might be performant enough. It does take a little bit of time to load the initial MITRE ATT&CK data, but it's probably within tolerance for a Lambda function. But yeah, certainly something to experiment with.
Cool.
Yeah, so I'd also like to add the ability to generate scenarios based on the techniques associated with different campaigns. Currently the tool focuses on the techniques that are associated with threat actor groups, but Attack has this concept of campaigns where you might see perhaps multiple threat actors working together, targeting particular types of organizations, and they roll that up into a construct called a campaign. So for those organizations that wanted to practice it being part of a campaign, I think that would be a useful addition. I'm also looking to add some options for users to provide more information about their organization. Conscious that probably many won't want to, particularly in the public version, and hence I'd make it optional, but it's something that I've done in some of my other tools. So I've got a threat modeling app called Stride GPT, where I just capture some basic information about an environment and an application, and then use that to generate a threat model. I think it would be additional useful context to help generate the scenarios for this tool as well. And lastly,
you need to tell us about the Stripe GPT. That sounds really interesting. I missed that one.
Yeah, so there's a link to my GitHub repo at the end. It's another open source project of mine, so happy for you to take a look.
Need to do another session on that.
And lastly, if anyone's got any suggestions, having watched this talk, please raise an issue on GitHub. If you're a developer, feel free to submit a pull request. If you're non-technical and have some ideas, then just contact me on LinkedIn. I'm hoping to make this an even more valuable tool for organizations as it evolves. So very happy to take ideas for improvements. And then, so sort of having seen an example of an LLM app, and I think it's a pretty good use case for the current state of LLMs and what they're capable of. I wanted to sort of move to wrapping up by thinking about different use cases, or how I think of different use cases for language models, and some of the tips really that I've thought of as I've carried on and learned things through the development process. So when it comes to identifying use cases, my favorite way of thinking about this and describing it to people is, imagine you had a new intern. They're very good at written English, or in fact any language. They will need supervision. They're not going to get everything right all of the time. They are definitely not your best red teamer, definitely not your best security architect, but they're very keen and eager to help. That's the type of individual you should be thinking of when it comes to thinking about, well, what would be a good use case for a language model. All the better if the tasks that you're going to give that intern are repetitive and or quite tedious tasks that can be easily automated. So setting aside hallucinations and other quirks of probabilistic models, Gen AI models don't get bored or lose focus like humans do. And so if you've got a very repetitive or tedious task, like generating incident response scenarios very quickly from a standard set of data, LLMs are really good at those types of tasks. And at this stage, I think it's really about augmentation of capabilities rather than replacement. So as I think we touched on at the top of the talk, it's really about, for me, making people more efficient and helping them to work quicker than it is about entirely replacing job functions or particular roles. And
so one of the scenarios that I really like with this is to explore. So I think there's two elements. I think there's post-incident to understand the other what if scenarios, right? So basically, like XYZ happens. So you can go, okay, but we got lucky because they turned right instead of turning left, or they didn't do this and didn't do that. So you can now start to see the next steps, but also I can see that an evolution of that is almost to do this in real time, isn't it? Where you almost start to predict what could happen next based on these possible scenarios. And then you could even take into account the existing controls of the company. Do you know what I mean? So it becomes super powerful. So you almost want to start thinking that a couple of steps ahead of the attacker, start thinking, are we ready for this? Are we ready for that? What happens if this happens? So I tend to do that in incidents, but this will bring a lot of science to that, and also will bring a lot of more, I would say, free dimensions to that exercise.
Yep, absolutely agree.
Yeah. George, I think,
George,
has the question. George, you should be able to speak. I think I made you a co-host. Although, if he's not, I think, actually, I think his question was, yeah, does AttackGen work API keys from other Gen AI servers as Bard or Bing chat? I think you kind of already said that you haven't really tweaked it for those, right?
Yeah, so it's limited to working with the OpenAI API.
Cool. Yep.
And so finally, just on identifying use cases, starting small with a well-defined use case is really key. So lots of organizations at the moment are just experimenting with simple use cases like chat with your security policies, and that's a fairly low risk consequence, because people should have a reasonable understanding of security policies anyway, and they've always got the ability to escalate to a member of the security team if they're not sure about a particular response that they received. And it's also it's very focused. It's not trying to replace the entire security team as your first use case. It's nicely scoped and manageable, and that then helps with some of the best practices that we'll come on to now.
Actually, that's an interesting point. Is it possible to add the scenario of what would this, if, like, for example, depending on the maturity of the security team, what would happen? Because at the moment you have scenario, right? But do you have the or is there how would you think of? Do you know what I mean? Like how can you add the current controls in place, including the fact that you have a security team that should react to some of these things?
Yeah, and that's sort of what I'm thinking of with that additional organizational context I mentioned in the roadmap. That's the sort of information that I would think of including. How capable are your security team? Do you have a permanent security team? Are you using an outsourced MSP to perform certain functions, or all of your functions? I think those will all have a significant bearing on your ability to respond and how you respond to an attack. So it's something that I'd like to at least give people the option to factor into some of the scenario generations.
Yeah, that could actually quite massive, man, because what you would also show you is the impact. For example, imagine doing that on budgets, right? Imagine doing that on simulations, and because I guess it doesn't have to be perfect, right? But if you have a team of a certain size, let's say same scenario against 3 teams, so one doesn't exist, one with some resources, one with medium resources, one with a lot of resources, or one without a lot of outsourcing, one without outsourcing, right? I think it would be quite interesting to run those scenarios. And again, you can do an LLM on top of the analysis of it. But I think that would be quite useful, especially around budget times and educations. And I guess even if you then start to have, another valid question here. Do you actually have, does this actually have real world scenarios on it? Like real world, instead of a scenario, almost like a real world attack?
So by virtue of the fact that it's the attack framework is all about real world observed techniques and tactics that these groups are using, then yes, it won't necessarily replicate.
Yeah, but they're not specific, right?
Sorry,
they're not specific.
No, but I don't think 2 attacks are ever identical.
Yeah, but that's an important narrative, right? Especially for in certain sectors, not, being funny, but personalizing some of these. Like, look, this attack just happened with this thing, with this kind of or industry or companies, but that could be added, right? That's just it's just a variation of the database.
I'd say it's already possible if you go through and do the custom scenario. So if you can get a threat intel report that says for that attack, which were the given techniques, you could build that based off the that custom scenario generation.
Yeah, no, that's very powerful, man. That it'd be great if somebody worked a bit on that one and shared, because or find a good way to do it, because you then have real world scenarios mapped to a particular industry, and then you add on top of that, for example, how would the current team or the react, or what would be the impact? That'd be really interesting.
Yeah.
Cool. Now, but I guess the foundations are here, isn't it?
Yes, yeah. So I mean, yeah, this is only version 0.2 at the moment, so it's still very early days, but yeah.
Good stuff.
So yeah, just sort of picking up.
Oh, Sarah has a question now. I was literally about to say, Sarah, I know you had some questions.
Sorry, no, sorry, I can wait. I want to let Matt finish, and then I'll pick up at the end.
Yeah, we've got 2 slides to go, I think, so we won't be too long. So yeah, in terms of best practices, we sort of covered, small, well-defined use cases. I'd also say non-critical use cases to start with is really important. No matter how compelling the use case, I wouldn't start off with a model that's making decisions about people, for example, or things of that nature. You really need to build up the organization's familiarity with the capabilities of the tools and where the foibles are before you start moving into those more potentially risky use cases. And to that end, human in the loop reviews remain absolutely critical at this stage. I have experimented with having sort of pairs of agents working together, which does give you that sort of chain of thought process that's been covered in some of the papers. But even then, if you were sending this report off to your CISO to say, I think we should do this, and you've not even looked at it, I'd be concerned if you were doing that. It still needs somebody that understands what the model should be producing in order to critique it and make sure that it is hitting the mark in terms of quality. If you are looking at making decisions during or by using a model, monitoring for bias, using things like that Lsmith or another tracing or observability platform is really useful. I think the major LLMs, OpenAI, Anthropic, Google, have done a really good job at trying to minimize the bias in their models. Some of the smaller models on, for example, Hugging Face, I think they've not been used and tested enough for us to be clear either way that there isn't an inherent bias in the model. So it's important to keep an eye on that. And also look at just fundamental engineering practices. So this is a relatively new field. We're still experimenting. It's important that you document what works, what doesn't, and track the performance of that throughout the life cycle of the tools that you're building. I'd also say be transparent about your use of AI. I think because we are at that early stage, users and even customers are very accepting of the fact that tools are experimental. But if they can see the benefits, I think they're prepared to accept some variation to what they would get from a pure human to human interaction. This is a conversation that I'm having more often, again, as the tools move from POCs into production, is really making sure that you're addressing that return on investment point. And so for something like AttackGen, you could look at metrics such as how many more exercises were you able to run in a year by using something like that tool, as opposed to if you were using a more conventional scenario generation route. And as you get more familiar with the tools and use them more across more different use cases. I think it's easy to become over reliant on them, and that's where things like human in the loop reviews, being critical of the models and not just accepting what they're telling you, is really important, because we've already seen quite a few well publicized examples of where over reliance has led people down a path that they really didn't want to find themselves on. And lastly, I'd say it's still really early days, particularly when it comes to productionizing these apps. And so I think it's incredibly important that organizations keep developing their own internal AI expertise and allow people to experiment, find out what works, and more importantly, what doesn't. That's all really valuable experience that I think we're going to need over the next couple of years. And so that's everything that I wanted to cover. I think Sarah, you had a question. I'm happy to take any others that people might have as well.
Yeah, that was brilliant, Matt. Thank you. It's just so nice to see something that's so concrete, practical, step by step thought through with all the caveats. It's just what I needed right now, anyway. But in terms of your model, it did occur to me, because I did in a lot of risk articulations which need a little bit of creativity to make them hit home, especially in incident scenarios. Would it be forgivable to just plug in the generated scenario and ask the model to compare it to any real life incidents that it could pull out, to maybe add some of that color, that sort of newsworthy color to it? Just as one idea. I don't actually see a poor impact as long as it's true to the mapped out scenario, to paint a bit of a picture for non-technical stakeholders.
Yeah, I mean, I providing that you're having a human review that, and someone that's capable of critiquing the output, I don't see a problem with that. I see it as a way of being more efficient. I think, as I've touched on during the talk, where people have got into difficulty is either they've completely relied on the output and not looked at it. So the case of the lawyer in the US that ended up submitting incorrect case studies with their submission springs to mind immediately. But
yeah,
there are also cases where, on a technical side, you can see things that once you go below the level of really good general knowledge, I'd say, then you can start to find weaknesses. So if you ask it really technical questions or really up-to-date questions, so beyond the training cutoff, the training data cutoff, that's when you'll start to get a lot of hallucinations. But in terms of getting work done faster, but still maintaining that quality, I absolutely don't see any issue with that.
But
yeah,
Sarah,
I mean,
were you talking about the scenario of taking an existing situation or existing incident and then augmenting with possible scenarios or possible, almost like offshoots of what could have happened?
But potentially, yeah. Well, either way, I was just talking about sort of potentially adding some more media friendly color to the attack scenario, for if you're potentially doing an executive tabletop or something like that, to bring that color to it. That was all. I mean, but I'm guessing you can extend it by sort of asking, what would happen next, but with all the same caveats that Matt brought to it, that it would need to be credible, it would need to be a logical progression, and defensible. I mean, the only other thing I was going to say is, I mean, I'm looking at what you pulled up, Matt, with your Python script to inject the techniques in there, because I'm looking at scenarios for mapping regulatory and legal compliance requirements across different frameworks, where we're to try and pull out some duplication and be able to actually have a conversation across control objectives and risk areas to pull out compliance requirements discreetly for types of businesses. So it's a very similar kind of thing in some ways. So it's a good caution for me to take away.
Yeah, so and the reason for doing that is because because of the to manage the risk of the hallucinations, but with a language model that had a really large context window, so like Claude, for example, you could just try pasting in the entire attack data set with your prompt. But it's got a couple of drawbacks really. One is the token cost. So then each input that you submit, each prompt that you submit would contain all of those tokens for the data that you were submitting, when actually you only need to query a small subset. You might as well do that upstream before you actually use the LLM. You also increase the risk of the hallucination or things not being picked up. So some of the research that I've seen recently is that language models pay more attention, probably a bit like humans. They pay more attention at the start of a large chunk of text and at the end. And then stuff in the middle tends to get lost. Whereas if you're doing like a regulatory framework lookup, you clearly want it to pay attention consistently so that you don't miss relevant clauses that are specific to what the query that you're asking.
Yeah. I mean, it could contract language as well. There's a potential use case for selectively based on context, putting contract language in based on the nature of the scenario and triage questions up front. And yeah, you really need that to be paying attention all the way through. That's good steers.
So happy to take any more questions. Otherwise, as I mentioned earlier on, there are the links to my profile on LinkedIn or to my GitHub repo. There's a number of different projects in there that use language models in different ways. I'm really all about practical applications for language models in cybersecurity and trying to make cybersecurity professionals' lives a bit easier through applying these tools. So there's sort of 4 or 5 different projects in there that you're welcome to check out, and they're all open source.
Cool. Now, massive contributions, man. And definitely, I think you're going on that direction of augmenting and making it a lot more productive, right? So I feel the other tools deserve a session too. So let's think up on that. So brilliant.
Okay,
well, thanks for this session, and the video will be up quite quickly. And then looking forward to the next version of this.
Okay. Thanks very much.